Hi, I'm Tina from Prep 101. In this video, I'm going to teach you about exponential functions. We're going to review the graphs, and eventually we'll get to exponential derivatives in this course. Okay, let's get started. Okay, so the first thing that we're going to review is just a graph of an exponential. You know, what does it look like to say we have an exponential function? And so in this first example, we've got the graph y equals 2 to the x plus 1. So we can think of this as the graph y equals 2 to the x, and then the x plus 1, we have to think opposite, so it would be moved to the left 1. So if you want to graph with transformations, you can do it that way. So you can do a table of values for y equals 2 to the x, and then shift it left 1. And otherwise, you can do a table of values right away for 2 to the x plus 1. Either way, you're going to get a graph that gets closer and closer to the x-axis but never touches, goes through 0, 2, because if we substitute 0 into here, 2 to the 0 plus 1 is 2 to the 1, which is 2. And then it's an increasing function, so it just keeps going up to infinity. Now, if they were to ask you the domain of y equals 2 to the x plus 1, we can put any x value we want into here. 2 to x plus 1, we can put x is -5, x is -5 million, it wouldn't matter. Same with positive values. So the domain is anything. So from negative infinity up to positive infinity. That would be our domain. Our range, however, if we haven't flipped the graph down or anything like that, if it's just an exponential function as it is, moved left or right, then we would have a range where it gets closer and closer to the x-axis but never touches. So this is our asymptote here, right? The x-axis. Or in other words, the line y equals 0 is an asymptote. And so if we have an asymptote, we never cross it. And so our range here is anything above 0. So we don't count 0, so we do a round bracket and then from 0 to infinity. Now, remember, if you had something like a reflection, then everything would switch. So you have to be careful. So reflection, if you had, so let's say y equals -2 to the x, this would make a reflection in the x-axis. And so your graph, instead of being y equals 2 to the x, so let's say we took y equals 2 to the x. So 2 to the 0 would be 1 here. And we took it like this. And we reflected it over the x-axis. Well, then it's going to be going down through -1. And so it would be kind of like this. And that would be your new graph. So always keep in mind of what transformations you're doing. If you had a negative in front of the x, then you would be reflecting in the y-axis because you'd be reflecting your x values here. So reflection in the x-axis here is a negative out in front, which is reflecting your y values. Okay, and if you had a negative up here right with the x, then you're reflecting your x values, so you're reflecting in the y-axis. And of course, this is our x, and this is our y. So back to this y equals 2 to the x plus 1, what is its horizontal asymptote? Its horizontal asymptote is the x-axis. In other words, y equals 0. And its x-intercept, well, it doesn't have one. It doesn't cross the x-axis. So the x-intercept is there's none. And the y-intercept is when you put x as 0 in, right? If you were to substitute x as 0 into your equation, what do you get? And you can see from the graph, it goes through 0, 2. If you don't have a graph on your exam and they ask you what's the y-intercept, that's a possible exam question, then you just substitute x as 0 into the original equation. We get 2 to the 0 plus 1, which is 2 to the 1, which is 2. So we can state the y-intercept is 2, or we can state it as a point, 0, 2. And that would be our y-intercept. So the other graph that you should know besides 2 to the x, 3 to the x, 4 to the x is, of course, e to the x, which we talked about in a previous video. And of course, we know that when we talked about inverses, that y equals e to the x and y equals ln x are inverses of each other. So if you look at y equals e to the x, it goes through 0, 1, goes down towards the x-axis but never touches, and then it goes up, it's increasing. And remember, y equals ln x is a reflection in the line of y equals x. So it goes down towards 0 here, right? And it never crosses the y-axis. And then over here, it's an increasing function. And so what would we do if we wanted the horizontal asymptotes and the x and y intercepts for these graphs? Well, let's do horizontal asymptote, x-intercept, and y-intercept for each of them. So if we look at, let's say y equals e to the x first. Well, if we look at the graph here of y equals e to the x, its horizontal asymptote is the x-axis, right? That's the line we never cross. So that's y equals 0. Its x-intercept, remember that y equals e to the x, y equals 2 to the x, 3 to the x. They go closer and closer to the x-axis, but never touch. So there is no x-intercepts. They do have y-intercepts, and the y-intercept is when you put x as 0 in. And so we get 0, 1 here. Now, remember that y equals ln x and y equals e to the x are inverses of each other. So the x-intercept of one will be the y-intercept of the other. So if we look at y equals ln x, well, does it have a horizontal intercept, a horizontal asymptote here? Well, if we look here, it doesn't get closer and closer to the x-axis, right? It gets closer and closer to the y-axis. So instead of having a horizontal asymptote, it has no horizontal asymptote, but it does have a vertical asymptote. And its vertical asymptote is right here. It's the line x equals 0. So that's for y equals ln x. And its x-intercept is right here, x-intercept at 1, or 1, 0. And its y-intercept, just like e to the x, y equals e to the x has no x-intercept, then y equals ln x goes down, down, down towards the y-axis, but never touches it. And so it has no y-intercept. It doesn't cross the y-axis. So that's a look at y equals e to the x and y equals ln x in terms of their graphs and their intercepts and their asymptotes. So one question that I've seen recurrently on exams is we can look at the graph of any logarithmic function. So such as we look at y equals log 2x, and then they give you some new equation and they say, you know, how would you get there? What would you do to the base graph of y equals log 2x? So this is the start. We can call it the starting graph. And what would you do to it to get to y equals 3 log 2 x minus 1 plus 3? So the 3 out in front, what do you think that does to the graph of y equals log 2x? Well, a number out in front is affecting the y values. So it's multiplying the y values by 3. And it's also called a vertical stretch of 3. So either of those. Now, the x minus 1 is in brackets. So remember, when it's in brackets, we have to think opposite. So x minus 1 is actually moving to the right one. And then at the end, we have a plus 3. And the plus 3 would move the graph up 3 units. And this one, on this particular exam, didn't have a negative. But if it did have a negative in front, so if, let's say, we made it negative 3 log 2 x minus 1 plus 3, then in addition to everything else, the negative would mean a reflection in the x-axis, flipping over the x-axis. In other words, flipping the y values, reflecting over the x-axis. Okay, so next we're going to look at the exponent rules that you should know from high school. And then we'll look at exponential equations that you should remember from high school. So exponent rules, there are 3. So the first one, when multiplying with the same base, we add our exponents. So if we have 4 to the 6 times 4 to the 3, we get 4 to the 6 plus 3. 6 plus 3 would be 9. So that's our first exponential rule. The second one is when dividing with the same base, we subtract our exponents. So when dividing, subtract your exponents. So the bases stay the same. 4 to the 6 divided by 4 to the 2 is 4 to the 6 minus 2. We subtract our exponents and we get 4 to the 4. And the third rule, the last rule here, is the power rule. And when you have a number inside and outside the brackets like this, you multiply your exponents. So 4 to the 3, all to the 4. 3 times 4 is 12, so we get 4 to the 12. And so those are the 3 rules that hopefully you recall from previously. And so simplify each of the following. So we're going to do a couple of examples here. So 3 over 6 we can reduce to 1/2. And then the base stays the same. And we have to be careful. We've got negative 8 minus negative 12. So just be careful of your signs here. So negative 8 plus 12. So that's 1/2 b to the positive 4. Okay, and one more, just to review your basic exponent rules here. 3x squared y cubed all to the 2. So hit pause and see if you remember what this would be. So the 3 has to get squared, and then we multiply our exponents. So x to the 2 times 2 is 4, y to the 3 times 2 is 6. So we get 9x4, y6. Okay, and example 6 here. So we have 3 to the x equals 1/27 to the 2x minus 5. Okay, so what we have to ask ourselves is 3 to what power would be 27, right? Because that's what we have on the right. And this is 3 to the x, so we can't make that any simpler. So 3 times 3 times 3, how many times gives you 27? Well, 3 times 3 times 3. 3 times gives you 27. Now, what do you do about the fact that the 27 is on the bottom? Well, that means it's a negative. So 3 to the 3 is 27, then 3 to the negative 3 would be 1/27. Remember, a negative exponent means put 1 over it. Leave the 2x minus 5 where it was. So keep copying down the left, 3 to the x equals, here we multiply our exponents. So negative 3 times 2x is negative 6x. Negative 3 times negative 5 is plus 15. And so what do we get here? Well, now we say if this expression equals this expression, and we're saying the bases are the same, then we can set the exponents equal. So we can set x equal to negative 6x plus 15. And then we can solve for x. So bring the negative 6x across, or add 6x to both sides. And we get 7x equals 15. And of course, we divide both sides by 7. And we get x is 15/7. And that's our answer.
I hope you found this video helpful. If so, see more videos in this playlist. Don't forget to join the Facebook Study Hub. Use the link in the video description box. Also, I hope to see you at my prep sessions, where I'll show you lots of tricks on how to ace your exam. I'll go through every problem that you need to solve, and you'll solve them with confidence by the end of my prep sessions. Many of our prep sessions are free, so go to prep101.com now for more details and to sign up. I hope to see you soon. Take care. Bye.